So here are most of the things I'm going to try to teach you today about polynomials, they're called. All right, so how many turns would this have? I cannot tell by looking at the information I have right here until I do something first. You don't have to multiply this all the way out, but you do need to multiply part of it out. You need the beginning and you need the end. Do you agree that a good story needs a good beginning of the story? If you read the first, 4 or 5 lines and you're like, this is really boring, you already don't want to read anymore. You need a good beginning and you need a good ending to your story that's kind of like gets everybody excited to see what happens at the end, okay? Well, we need to know the beginning, which is negative x to the third. Can you see how I got that? If I had taken the time to multiply this all the way out, I kind of did this in my head. I would have had an x minus 5 and another x minus 5. And if I would have multiplied that out, that would have had an x squared in it. And then there's this x plus 1 at the end. And eventually the x squared would have got around to multiplying by the x. So this is a skill. Can you go x squared times x makes x to the third, and oh, there's a negative in the front, so it would be negative x to the third. Do you get how I did that? That's the first thing you do, is find what's called the lead term, because it tells you like tons of stuff. It tells you what degree it is. You might have thought from looking at the red one that it would be degree 2, but it's not. It's degree 3. The biggest degree, which is this little number right here, gives you the degree. The biggest degree is 3, and so then you're done. You don't have to worry about the rest, all the little terms in between. Like, what if there was an x squared in there? I don't care. What if there's a plus 3x? I don't care. The last number, though, that matters. The last number I get by doing negative 5 squared, because see, here's my negative 5 times my negative 5, and that would make, would you agree, positive 25. But then this negative in the front would kick in and make it back to negative 25 again. Then I would times it by the 1, but that doesn't really do anything, because when the positive that turned into a negative 25 gets times by 1, it's still negative 25. So then this negative 25 is a big deal. Why? Because it's the y-intercept. So do you see that the beginning and the end are what's important, and I don't care. I just made up stuff for the middle. It doesn't even matter. The y-intercept of negative 25 shows up on my graph. It's like down here. You can just call it negative 25. You don't have to number it all the way down to it. You can just say, well, I know it goes through that. I know it goes through 5. Do you know how I knew it went through 5? Because that's one of the x-intercepts. And then how about negative 1? Do you get how negative 1 would zero out the function and give you y equals 0? If x was negative 1, that's the same as an x-intercept. Do you get how I knew it went through those 3 things? Okay, this is a lot, I know. Next thing is, generally your graph's going to kind of look like this. It's going to go through the key points, but it's going to be a wave. It's going to kind of go up and down. And so I'm going to say, well, I think it might look something like this, but does anybody remember something that would tell me that that is wrong? Because it is. I've gone through the 3 important spots, but I didn't do it right. You remember something, Ruby?
Isn't there a negative function?
There is a negative on the beginning, and what does that tell you? That the function has to go down on the right. If you didn't know that before, I forgive you. The function has to be going down on the right, and mine wasn't, so I'm erasing it, and I'm going to fix it. My function has to be going down on the right. That right there means down on the right. The right side's down. Another thing that you learned in higher algebra is that when these are odd, the ends go opposite ways. Do you guys remember that? When it's an odd degree, then the ends go opposite ways. Ends are different. That's a Minnesota nice way to say that you're being kind of odd. Oh, that's different. Different, odd, see, they kind of go together. So if you have a degree 3, then the thing is obviously an odd number. And if it's odd, then the ends will be different. So I know this end is going to go down because of the negative in the front. I know it's going to go up on this end because it's an odd degreed polynomial. Next thing I remember is there's something about a bounce. Does anybody remember where the bounce would be? The original problem is the red one here. Yes?
Only 2x-intercepts, so would it like bounce at 5 or something?
You are exactly right. See, the fact that there's a 2 right here means that there's a bounce that's going to happen in this part. So that's bouncing at the 5. That was the key. And that's what this graph looks like. Do you get how I got the y-intercept? I multiplied it all out and figured out what number was at the end. Do you get how I knew it was down on the right? Because it was a negative in the front. This part. Do you get how it was up on the left? Because this was odd. So they're going to be different. And why was it bouncing here? Because of that squared right there. I know that's a lot. See if you could do another one that's like, oh wait, there's more questions here. How many turns does this thing have? Well, let's look at it. If you think of this as like driving across a parking lot and you were heading this way and then all of a sudden, oh, I got to go back to where I came from. Oh no, I'm going to go back this way. I took 2 turns. Turns has to always be 1 less than what degree you have. This has degree 3. So I can only have 2 turns. Did I have 2 turns? Yes, I did. I had 2 turns. There was a turn, and there was a turn. All right, so how many turns? 2. The lead term, that's this thing, negative x to the 3rd. The y-intercept, we figured it out a while ago, it was negative 25. The x-intercept, well, there's actually 2 of them. X equals 5, and x equals negative 1. The bounce, oh, that was at 5. The degree, that's this 3 up here, that's the degree. And the lead coefficient, there's no number there, Mr. Server, you screwed up. Nope, there's a 1 there. And so negative 1 is the lead coefficient. All right. That's a million things that you used to know, and you might not still know them all, but that's a review of a million things. Yes?
How'd you get the 5 to be a bounce again? How'd you know that?
I'm going to do a different one. Guess what happens at the 4, Joe? There's a bounce. Because of the 2 here. All right, let's see. If you had to, could you tell me the beginning of the story and the end of the story? Well, it's got to be y equals x to the, can you do it in your head quick? X to the what? 3rd, good. Because that'd be this and this getting multiplied. Did you notice there was no negative on either of the x's? And there's no negative in front. So you get, there's no negative right here. So that means it's positive. That means the right end is going up. Because the lead term is positive, the right end is going up. Because this is odd, they have to be going opposite directions on the ends. Like one end's up, one end's down. And since I know that it's positive, it's like there's an imaginary plus sign right there, then this has to be going up on the right, and therefore it must be going down on the left. It's got 2 turns. Its degree is 3. Holy cow, there's so much stuff. I don't care about the in-between. I just care about the end of the story. Davis, can you do negative 4 squared in your head? Can you do 16 times 5 in your head? All right, it's 80. if you can believe me that 16 times 5 is 80. Can anybody verify that? Do you think I'm right? Okay, good. Then, do you agree that this 80 here is the y-intercept? Y-intercept is where x equals 0, so all the other parts would just cancel out, and you just have y equals 80. Okay, so if I had to graph this thing, here's my quick graph. I know that it goes through 4 and negative 5. There's 4, there's negative 5. I know it's going to bounce here. I'm just going to say boo for bounce. I know it's positive in front, so it's going up on the right. I know it's got a odd degree, so it must be going down on the left. It just passes right through this one. It does not bounce at the negative 5 because it has a multiplicity of 1. That's another word I haven't used much. That 2 is its multiplicity. This 1 is its multiplicity. It's like the power. It's called its multiplicity. I know it's on a test. I remember the honors pre-calc. I used to teach honors higher algebra. I know it's on their test. It's called multiplicity. And that's just the name of the power. Okay. And then I go over and I bounce off of here, boing, and then I go up. Now, does my y-intercept match? Yes. The only thing is it would be way higher than this, but I wouldn't mark it wrong because you can use any scale you want. You can say that's 80 and then you're good. Okay, that would have been a right answer. You went through this x-intercept, and this y-intercept. You're going up on the right and down on the left. I only had 2 turns though. Does that match up? With degree 3, you would have 2 turns. Yay. Now, I have to, I'm sorry, I wish I didn't have to make it more complicated, but I have to make it more complicated. Ruby, that was in your backpack. Please don't make me talk to you about it again. I really wish I could just say it always will have 2 turns, but it has at most 2 turns. Dang it, math gets complicated again. It'd be a little bit like this. Would you agree that if you're teaching a new person to drive, that you can say, well, don't worry, if they hit you, it'll be their fault, and they'll have to pay for the accident? That's kind of true, but it's more complicated than that. Do you get if you slam on your brakes, somebody hits you from behind, it's their fault, and they're supposed to pay for the accident. If you didn't know that, it's true, but what if they have no money? Is your insurance just going to fix your car? Yes, but then you have to pay what's called a deductible. So you might have to pay for something even though it totally wasn't your fault. If you have like $1,000 deductible, you have to pay $1,000, and then your car gets fixed by your insurance, if you have insurance. Because this other guy, totally his fault, hit you, you might end up having to pay. Well, shouldn't his insurance pay? Yeah, but there's more than 12% of drivers out there who do not have insurance. So when they hit you, sometimes they just drive off because they're like trying to make sure you don't catch them. It's totally illegal. They can go to jail for that, by the way, so don't drive off. But if they don't have the money, it might be that even though it's their fault, you have to pay. That sucks, but it's the reality. It's complicated. Life gets complicated. Well, I wish I could just say that since this has degree 3, that it automatically has 2 turns, but no, it has up to 2 turns. I'll give you an example. Would you agree that this is the x to the 3rd function? It doesn't have any turns. It doesn't have any turns. It could have had as much as 2 turns in it if I had done something like this. Then it would have had a couple turns in it. Wouldn't have actually looked exactly like that, but that has 2 turns. That's the most turns it could have, though, is 2. But it doesn't have to have 2. It can have less. Why? Because there's something called imaginaries. Life would be so much simpler if we didn't have imaginary numbers. But believe it or not, some of what we do with electric equations couldn't work without imaginary numbers. They're doing things now with electrical engineers, do stuff with imaginary numbers that allows them to solve equations they could never solve before. And so some of the inventions that you have, like in your hand, like in a cell phone, depend on electricity flowing through wires and circuits and things that they wouldn't be able to have figured out if they didn't have imaginary numbers. But imaginary numbers make things complicated. This could have imaginary roots and you wouldn't even see where they are. You can't see them. Would you agree you can't see imaginary things? Like the Loch Ness Monster, you can imagine it, but it doesn't really exist. I actually think there are giant sea creatures that we've never seen. But the Loch Ness Monster is in a freshwater lake. I'm not buying it that there's a freshwater, crazy-looking swamp creature living in Loch Ness in Scotland. But in the ocean, I think there are things we've never seen before. So, but they're not imaginary. They're real. We just haven't seen them. True. Great, these huge squid. Never seen them before. Doesn't make them imaginary. They've actually seen these giant scars on whales that are from these giant squid that we've never actually seen before. There was a picture of one kind of giant squid that they saw for the first time by dropping a camera super deep and having a lure to try to bring in a giant squid, and they got images of a giant squid for the first time. And you know what it looked like? A big squid. But it's just hard to get perspective. It's so huge. Their eyeballs are like this big. An eyeball. Like, it's just massive things down there. But imaginary things on a graph you can't see. They're like leprechauns. You know they're there. But you can't see them. All right. So this has a degree of 3 and yet no turns. Because it was going this way and then it's still going that way. Just kind of swerved a little bit. It's not a turn because it never changed directions. It always kept going up. It was always increasing, and that's a degree 3 just as much as this one is a degree 3 that's got a couple turns in it. They're both degree 3. I wish it was simpler, but it's complicated. Degree 3s can have as many as 2 turns. Okay, now let's see if you can pass this test. How many... or what degree would this be? What degree is that? Say it if you know it. Degree 4. What's its y-intercept? -1. In this case, I'll save you some time. It won't factor. So you wouldn't be able to find the what's? X-intercepts. Good. Can you tell if it's going up or down on the right? Up on the right because there is no negative there. Therefore, it's positive. Therefore, it's up on the right. Okay, the other end then. If it's up on the right, what's the other end doing? Since this is even, if it's up on the right, it's also up on the left. So, is this graph up on the left and up on the right? Yep. Does it go through -1? Well, I'm going to make it go through -1. And then I'm going to make it have a little dipsy-do like that. Would Mr. Server mark that as a possible right answer? Well, I don't know what the x-intercepts are any more than you do. So maybe it has these x-intercepts. 1, 2, 3 turns. Is that legal to have 3 turns for this one? Yup. Could have 3 turns. Up to 3 turns. Goes through -1, up on the right, up on the left. Passes all the tests. I'd have to give credit for that. What if Lazy Larry just did that? Would that blue one also get credit? Yep. Still has the same y-intercept. Still up on the right, still up on the left. And I don't know what the x-intercepts are. This only has 1 turn. How could it only have 1 turn? Because there could be imaginary roots that I can't see. All right. Riddle me this. What's different about this one that makes it a little harder, but a little easier at the same time? Yes. It's already factored. How does that make it easier? Very good. How does it make it harder?
Yeah.
It's harder to find the what? The y-intercept is much harder to find. Could we still figure it out? Yes. Everybody try to use this, this, and this to figure out what the heck the y-intercept would be. Remember how I said the beginning of the story and the end of the story is what's important? The beginning of the story is it's negative x to the third. I think most of you could have figured that out. But the end of the story, I hear a calculator popping open. I totally get it. You probably aren't doing 4 squared because that's 16. You're probably not even worried about the negative because that's negative 16. But negative 16 times negative 8 makes positive, I don't know either. Sounds believable. Can anybody verify 128? Okay, good. Then that's the first step. You figure out the beginning of the story because now I know it goes down on the right. Has to be going the opposite direction on the left because it's odd. It's degree 3, and it has a y-intercept of 128. Think you could do all that? All right. Then the last thing I need to teach you. Last melon. This is called a sign chart. Imagine for a moment we have that sea monster. This is our function. I'm going to ask if this is a possible equation for it. Everybody write out what you think the equation is. And I think it has an x, and then an x minus 3, and then an x minus 6. And then I think it has one more, an x plus 3. Can you prove I'm wrong? Yes. Ooh. The y-intercept. The y-intercept is if I multiplied this whole thing out, the thing that burned you is that there would be an x that would multiply then by everything. So this one would end up having this number that you're thinking would be there, but it would also have an x on that number because that would get distributed to everything. And so then there isn't any y-intercept, which means the y-intercept is 0. Another way to say that is this. Would you agree it goes through 3? Would you agree it goes through 6? Would you agree it goes through negative 3? But that right there means it goes through 0, which is what that is doing, and the y-intercept is 0. So can't prove I'm wrong yet. Goes through 0, 0, so that's 0, and that comes from that. Yes?
It would bounce at 3 because you put x minus 3 on both sides.
Oh, I have an x minus 3 and an x plus 3. Those are not the same thing. I get it. If those had both been x minus 3s, you're right. It would have had to bounce there. But these are all passing through. Degree 1 means they just pass right through. And that's when it just goes right through. It doesn't bounce off of it. It goes right through it. That I'd have to give credit for that one. That would have been right. And then here's the thing that you have to be able to do from that. Do you remember when we set things greater or equal to 0 that then we have ranges for the answer? Okay, hold on. If your brain didn't explode till now. What if I said this thing is greater or equal to 0? Oh my. Then it'd be better to just look at the picture. Would you agree that in this zone right here, the function is greater than 0? And how about in this little zone right there? Was it also greater than or equal to 0? And then how about this part? Would you agree in that area it's greater or equal to 0? Then this is what's called a sign chart. And that's the last thing I had to teach you today. And you've never seen one of these things before. Between 3 and 6, do you get that the function is below 0? Then it's negative in there. Between 0 and 3, do you agree that the function is above 0? Then it's positive in there. Between 0 and negative 3, do you agree it's below 0? So it's negative in there. Way to negative infinity, it'll be above 0. And it'll be above 0 here also. So when were the moments when this function was above 0? From negative infinity, I'm reading it right off of here. From negative infinity until negative 3, it was above 0. Union with, then it was above 0 in here, which would be from 0 to 3. And then, I think these are all brackets too, dang it, because I said or equal to 0. So bracket, 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 because it hits 0 there. And then it's also above 0 from 6 to infinity. So I say union from 6 to infinity. Whew! That's rough. That's everything, though. And if you feel like I just taught you a ridiculous amount of stuff and you don't get it all, then you're normal. Because I just taught you about half of your next test. Because I really couldn't just like skip over parts of that. So I taught you everything from that whole like area of polynomials. And seriously, I know what the test looks like. And I just taught you half of the test questions. So if you feel like I just taught a lot, I did. Do you think I expect you to be able to pass a test on it at this second? No, the test isn't for like a week. So I'll review this stuff.
Will you do the second half tomorrow?
No, you're not going to learn all. Man, that'd be amazing if I could teach you the entire unit in 2 days. No. But we'll definitely review this stuff. So don't feel bad if you don't feel like you caught everything. All right. So that's called a sign chart. If I gave you this graph, it's supposed to hit there at that spot and this spot, would you be able to say, in this zone, it's positive. In this zone, it's positive because it's still above. And in this zone, it's negative. That make sense to you? So if I said, when is this function positive? Well, I'm going to give you numbers. This is where 0, 0 is. This is at 4. This is at negative 3. And I'll call this the the blue zone. That's the only place it was negative. In this zone, it was positive. So between negative 3 and 4, it was positive. And in this zone, it was positive. Between 4 and infinity, it was positive. And that's called a sign chart. Yes?
Wouldn't that just be bracket negative 3?
If we include 0, yes. But if we said, when is it just bigger than 0, then this spot itself, it is 0. So it's not bigger than 0. So if I wanted, when is the function greater than 0, I would have had to say between negative 3 and 4, it was bigger than 0. Union with 4 to infinity. If I change this to an or equal, then I'd want brackets, and I would also have included the 4, which would have meant I could have just said from negative 3 to infinity. Okay, I know there's a lot, but there's even one thing I didn't teach you that was on the notes for today, so it was absolutely ludicrous day. Plus, it's a Wednesday, so it's shorter than normal. So there's one thing I'll come back to. So let's go through and just talk about each slide a second. This is just a reminder that the tennis ball lab is due today. If you haven't turned it in yet, you got lucky, because I meant to have it due this morning at 8 a.m., but I did not. I set it by accident to the end of the day today. So you can continue to work on it and turn it in today. Why would you want to kick your butt and do that like really fast between now and the end of the day? Because if you turned it in late, you lose 10%, and it's a summative grade. Okay, so that's going to hurt. So I strongly recommend turning it in today, because otherwise you have to gamble that you're going to do it so good that when you take off 10%, it would be better than if you just hurried up and finished it. Okay, so hopefully you've already done it, and just don't forget to Dropbox it. Next thing, what is a polynomial? These things are polynomials. Even if they're weird looking, And next thing is the end values. You know, this is down on the right, down on the right. This is up on the left, up on the left. There's a lot of different ways they could be down on the left and up on the right, for example, or up on the left and down on the right. Think about those. This is just the zeros. We talked about zeros already. And more about when they're up and down on the left and right. We talked through that. If you had to sketch this one, would you know it went through -5? Would you know that it was up on the right because it's positive there? Can't factor that one, so I don't care about the x-intercepts. And why do I know that would be wrong?
That's what down is.
Yep, because it's odd, it would have to be down on this other side. Could Lazy Larry get away with this graph? Yep, because it goes up on the right and it goes down on the left, and it goes through -5. It didn't have to have 4 turns. If you wanted to make it have 4 turns, you could. All right, good enough on that. And that's the problem that we will for sure talk about tomorrow. And this is just a reminder that this 3, you know how 3 is important, right? 3 is the 0. The multiplicity is the 5. And that's called a cut through because it didn't bounce. This one's called a bounce at 6. And its multiplicity is 2. Multiplicity just means what's the power on it. And this one would be a 9 is the 0 because it would make it equal 0. It's got a multiplicity of 1 and it just cuts through there. If you don't want to call it cut through, you can call it a pass through. I'm fine with either one of those. The only ones that do something weird is the bounce. Okay. Not going to make you do a sign chart. We just talked about those a second ago. And here's the ones I think you should do. You should do those two. Problems 2 and 7. You got to admit, I cut your homework way back. I hope you, in turn, actually do those at night. Because some of you are going to get your test back and you're going to be like, dang it, I got a B. And I wanted an A. Well, this is how you try harder, is you actually do the homework at night. And you check it. I would skip that because I don't think it'll help you. I would do 13 and 18. But skip the middle one. And I'd skip the rest of them. And that's enough for one day. If you just did that tonight, it would probably only take you 10 minutes. But that's so much different than the kid just going, I think I got this, I'm fine. You probably aren't. Especially today. It was really complicated. All right. Then that's all I got for you for the video for today.